Hello, and welcome to another video in our IoT series. Here we're going to start to look at maybe more the topic on IoT, the industrial IoT, the industrial Internet of Things. And we're going to start to see how we can get a very common industrial controller to embed that as part of an IoT system. And this is going to follow a series of videos of how we do that. But we're going to look at one way of doing it, and we're going to use the Siemens controller. It's a Siemens ET200SP. It's part of the 1500 range, and we're going to see how we can use a couple of different protocols, a couple of different pieces of software to get data up onto the cloud, and then we can start to do some more interesting things from it. So we've got to look firstly at the PLC side of things, and I'm running this off TIA Portal V14. Okay, so it's an older version. There's a couple of differences within the newer versions, but to be honest, all it does is just make it a bit more easy. So we're going to look at the V14 version. I'm just going to create a project. I'm going to call it OPC PLC video because OPC-UA is the communication protocol that is going to initially start us on our journey to embedding this as an IoT device. So we're going to hop in straight into the project view, and what I really want to do here, I'm just going to set up a little bit of logic for the PLC so that I can control an output with some inputs, and that I can see a variable that's changing all the time. So if I want to visualize it on a dashboard, I can see that kind of in real time, and I know my system's working. So I'm not going to do a huge amount of logic here, but just a little bit. But the first things we got to do is we've got to add in a new device. So what we have is an ET200SP, and this is the particular one I'm using. Okay, and I'm going to go with the latest version. It is important that you update, especially if you're using Siemens V14, you update your PLC to the latest firmware edition. That's quite important. So even though I'm using older software, I'm going to use the latest firmware on my system. So do keep that in mind. If you're having some problems, you need to update it to the newest firmware. So I'm going to add in, I've got some input cards. I'm just going to add in these quickly. This is all fairly standard stuff. Add in 2 input cards and 2 output cards. I'm not necessarily going to use everything that I have here, but I just want to set it up exactly with what my hardware would be. Okay, so that's going to be there. Now the other thing I'm going to do is I'm going to go ahead and add in my Ethernet address because I would be using this with the hardware. So just give me 1 second until I get my IP addresses required. Okay, so I've updated that for my PLC hardware. Now the other really interesting thing we're going to do in our hardware is we're going to set up an OPC communication. Okay, so that's a protocol that we can use to communicate with a particular type of software that we'll see in a later video called Node-RED. And that protocol is a link between, as I said, between those this software and this hardware, and it's a link to a particular software platform, as I said, Node-RED. And then we can do further communication to get that data up into the cloud. So because we've got no Wi-Fi on the PLC that I'm using, I'm going to have to use kind of the Wi-Fi from my laptop. So I need to get the data onto my laptop locally, store it on a particular application, and then push that up onto the cloud. So we'll explain that a little bit further, but essentially the first protocol I need to use is OPC. So I can look for the OPC settings. I just go into my device here, and then we will scroll on down, and you'll see we've got OPC-UA, so Open Protocol Communication Unified Architecture. And we've got a couple of options. The first thing we're going to do is we're going to activate the server. So essentially this PLC is going to act as an OPC-UA server, and then we're going to connect it to a client, which will be the Node-RED. So we've activated. Really important, what it's given us is the server address that we can get locally and the port number that we can get it locally through our kind of Ethernet communication. We see the port number. We can set up some values. Usually you're looking to try put these as low as possible, and with this particular PLC, that's really what I'm getting. So there is a bit of delay, 500 milliseconds, not crazy, but do keep that in mind. As we scroll down, we can set some security settings. You can keep some basic security settings if you want. You can go to no security. I'm just going to keep some basic security at the moment, but it's all going to be fairly loose just for the sake of this video. Yeah, that's kind of another area of IoT getting into the security. So we'll keep scrolling down just to see what we've got. We're going to enable people to log on to it. And yeah, that's the main setup there of the OPC-UA server. Now, just some other things to keep in mind as we scroll down. You will see some connection resources, and it is important to know how many connections we can actually make with other clients, so other software packages and things that can connect to this. There is a limit with the hardware. And then finally, we do have to add in a license for this. Now, this isn't, you don't have to buy this license or anything like that, but you do have to say that you're using just a small license. Okay. And that will set up an OPC-UA server in our PLC. So once you download that in, that will give that characteristic and allow us to communicate along the particular web address or the particular Ethernet address with the port number and communicate with other software packages. So that's been set up for us. And then I want to set up a bit of logic to link in with that. So what I'm going to do is I'm just going to create some tags. And usually I'd have an input and output table. I may even have a memory table. And what I'm going to do is I'm going to have an OPC table as well. So a lot of different tag tables just to kind of keep organization. But we'll have inputs, we'll have outputs. So these are my real devices. We'll have just a memory table for some memory bits that we use, and then also these are going to be my OPC tags. Okay, so anything maybe I do control via dashboard, this will be some of the tags to get me in there. So inputs, we're not going to be doing too crazy here. Let's just do a start push button and a reset push button. We'll assume they're all wired, normally opened. My outputs, I'm going to go ahead and just pretend I'm connected to a motor here to give me some particular output. Make sure that's percentage Q0.0, and then I'll come back to the other tags as we start to define our logic. Okay, so these are kind of tags, inputs and outputs, user inputs that I want to utilize or eventually want to utilize with my IoT protocol. The other thing that's useful is just going to be to display some data or to pass some data through this IoT architecture. So I'm going to create a data block. It's going to be called OPC. I'm going to enter in that, and then I'm just going to create a variable. I'm just going to call it variable 2, and it's going to be an integer. And yeah, that's really it. You could pass a couple of variables in here, but what I really want to do in this video is I'm going to set up some logic that's just going to make that variable change constantly, so that when I want to view it in real time or when I'm doing some testing, I can actually see that variable changing by the PLC, and I know I've got everything set up correctly. So a couple of things to set up, and then we'll go into our logic. I said I'm only going to do a simple system here to prove the architecture, and then you could develop your PLC code a bit further. So something I want to do is I want to just see an output turn on. So a usual sort of thing, we can set up a bit of a latch here, and let's just say we have our start push button, and then we're going to have our reset to break the latch. We'll assume everything's normally opened. We have our motor, and then we can latch that motor on. Okay, so I've got some hardware that I can actually influence that that motor output. But then what I also want to do is, well, I also want to be able to trigger that via a kind of OPC link or via my dashboard. Okay, so how I'm going to do that is, well, I want some tags. So what I'm just going to do is I'm going to have an OPC kind of start push button, and then I'm going to also have an OPC reset push button. Okay, now these aren't real devices, it's going to be from a dashboard, so I've got to use memory bits for these. Okay. And what that'll allow me to do is basically just give me two ways of controlling this motor. I can either control it with my kind of dashboard links, my OPC communication, or I can do it with a real device, the start push button. And again, we can break it either way. So that's just a bit of logic that I can do to visualize some actual output, some actual things happening. And then the next thing I want to do is, as I said, set up a little bit of logic so I can view a variable just changing constantly so I know I have something set up. So the way I'm going to do this, I'm going to set up a couple of tags again here in memory. I'm going to have a run mode, rub mode, not run mode. Remember this is percentage, where are we? Oops, percentage M, and we're on 0.2, I believe. So I'll hop in here. Right, so we're just going to start a run mode. And the logic I'm kind of thinking is I'll put in a timer, and every 10 seconds I want a value to change. Okay, so timer 1, T hashtag 10 seconds. Okay, so I'm going to use the run mode, which is just constantly on for us. It just turns on automatically once the PLC starts. And that's going to power timer, and then once that timer times, I'm going to turn on another memory bit. So we'll just go timer reached. Okay, as I said, this logic is just a quick bit of logic. Okay, there's no real thought process or structure to it, but I'm going to turn on another input. Okay, so I said timer reached. So once that timer gets reached, I'm going to put a value into a counter. Okay. You know, there could be an easier way to do this, but this is just a nice little bit of logic. So essentially, once the timer gets reached, it's going to trigger my counter. Okay, I want my counter, let's just say it'll count up to 150. So every 10 seconds that'll increase by 1. I'm going to guess 150 will eventually put it back to 0. And I'm going to store that value into my OPC data block and into that variable. So this will constantly be changing. This will be showing me the value of my counter. Change every 10 seconds. Every 10 seconds it will increase by 1. Then it'll eventually go back down to 0. So what I need to do again is I need some memory. I need my counter reached. And I'll also need a counter reset. Okay. So back into my main. So once the counter reaches, we can say counter reached, and then we can just pass this very nicely. Counter reached into counter reset. A little bit of memory logic here for everybody to see. Counter reset, and then that counter reset can go into here. So let me just check that again. A wee bit more to add. So run mode will just come on automatically. Run mode will time up to 10 seconds. It will turn this on, counter reach, and we'll get a pulse into our counter. Now we need to, once that counter gets reached, we need to actually break that. So that once the timer gets reached, it will give a small little pulse into my counter, and then ultimately break my run mode, which will turn off this timer, turn off this value, it'll go back to 0, and then this will turn back on. So run mode will keep, they'll kind of keep recycling each other. That'll keep happening until we get to 100 or 150. 150 counter will reach, that value will turn this on, and then that will eventually just reset the counter. So we'll get like a sine wave, or not sine wave, sorry, sawtooth wave that is just increasing by 1 every 10 seconds, go up, 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 and then straight back down. Up, 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 gradually, straight back down. Okay, so that's my logic for what we wanted to do. And I said all I did there, a little bit of logic, just control one real output. I've got 2 real inputs that I can do to control it. Where is it? Start and reset. Just going to latch on an output. And then I have this OPC kind of memory bits that I'll use from a dashboard to then control this, just so I see that that OPC communication is working. All right. Then the other thing I want to do is I just want a value that's constantly changing for me, so that I can see it in real time when I eventually want to pass that into a dashboard or something, so that I know that that's just happening. So I'm just doing that wait a timer. Every 10 seconds, it's going to increase a value in a counter, and I'm just storing that in a data block for me. That's nicely labeled. So nothing too fancy, but just a little bit of logic there, so I can prove the connections and the structure is working. And then you could, of course, develop your PLC project whatever way suits you. So this video is going on a little bit long, but it's covered all of the PLC side of setup. Then what we're going to do is we're going to look at another little program that's needed kind of as a middleman, but we're already just viewing a little bit of the OPC-UA properties, and then we'll go ahead and set that into Node-RED and see how those data can be passed locally into a version of Node-RED. Then we'll use Node-RED to push that data up into the cloud.